The best way to learn science process is to do science. The Learning Plate Tectonics with Data workshop provides all of the tools you need to offer your students authentic investigations of the theory of plate tectonics. Elevation profiles, seafloor age, and earthquakes are the primary data that supports the theory. Using these data, different types of plate boundaries and variations among different plate boundaries of the same type can be studied. Volcano distribution and ages provide additional evidence. Volcanic island ages can also be used to determine plate motion over mantle hotspots. Real-time earthquake data can bring the reality of ongoing plate tectonic activity to life. Current earthquakes are accessed from the USGS and plotted on the map. Information about a quake is displayed by clicking on its symbol. Students can then relate current quake activity to plate tectonics configurations and theory. The Learning with Data desktop is the control center. Learners select background information resources, animated slide presentations, and activities from drop-down menus. Learning the theory is supported with a selection of lectures that address the interior and surface expressions of plate tectonics. A series of inquiry activities set up basic, then more in-depth explorations. Background information is readily accessible from drop-down menus. Here is an excerpt from a plate tectonics presentation that was created by Dr. Tanya Atwater.
Most modern Earth scientists believe that the continents have been in nearly continuous motion since the very first ones were formed, billions of years ago. Let's imagine making a cut into the Earth through Africa and South America. The following animated cross-section depicts our modern idea of what happens beneath the surface of the Earth as the continents drift.
Resources in each subject module are accessed from an index that presents background information and activities in a logical order. The next step in the investigation is to collect and annotate the data images that will form the core of the student's scientific argument. A built-in image editor enables a student to combine data plot images and add notations and captions. The image editor supports free-form drawings and can acquire images from the clipboard and local files. This makes it possible to get images from web pages and those created with other image editing programs. Learning with Data contains activities that help a student create and assess a scientific argument. This activity encourages the student to describe a data plot in scientific terms. Another activity asks the student to analyze and compare two written arguments that embody various rhetorical issues. There is a document that discusses science writing styles, including a section on the use of figures. These documents can be printed and distributed to students for out-of-class reading. So, to summarize, the suggested learning steps are for students to first explore the data to become familiar with the software. Next, learn to understand the theory. Then seriously investigate the data for evidence to evaluate the theory. Then assemble the data and create the scientific argument. Next, present the findings to others in the form of a lab report, writing assignment, poster, or oral presentation. And finally, to receive feedback from the teacher and/or peers. This method embodies the fundamental features of the process of science.